Okay, you got a little misprint here, but first off, I want to find the solution set. Notice this is an equal right up here, but before I can solve it, I need to get only absolute value on the left side here. So I'm going to add 5 to each side. Now that I can solve it, what happens, it means is this. It means the answer works when I get a positive 1 for an answer or a negative 1. Because what's the absolute value of negative 1 is positive 1. So that's why I put that little negative 1 on the left, the one on there. Not, those negative 6s shouldn't have popped up yet. Now they should have popped up so we can what? Subtract 6 from each side to cross them out. This is my little trick. I kind of do all three at once. So negative 1 minus 7, 6 is negative 7. 1 minus negative 5. Now I'm going to divide everything by 3. Those will cancel out. So here's my answer. Negative 7/3 and negative 5/3. And you're going, wait a minute, you have a negative and you get a positive? Yes. Because what's going to happen is when I take that negative 5 times the 3, 3's are going to cancel, so I have negative 5 plus 6, which makes positive 1, which will be 1. And when I do the same thing, 3's will cancel out with the negative 7, and negative 7 plus 6 is negative 1, which becomes a positive 1. That would be the solution set. But what about when you graph these inequalities? Well, first off, I like to do this here. I'm trying to determine whether I look up here, I'm looking for values that are smaller than 7, so I know they're going to be between negative 7 and 7. Kind of, I call them ends. And I just use my numbers like that. I put that negative on the other side like that. And then I get rid of the parentheses and just add 3 to each side. So I know that my answers are between negative 4 and 10. And I put these as open circles because there are no bars, so it's not equal to, and are determined that we're looking for values that are inside. All right, I like to kind of do it that way. I think that's the easiest way to kind of understand it. Looking for values smaller than 7, but that means they have to be larger than negative 7 to be smaller than 7. Which when shifted by the 3 makes the answers negative 4 and 10. Okay, so here we have the absolute value inequality in the graph of the solution on this number line here. This time it's different. I'm looking for values larger than 3, which means they have to be smaller than negative 3, so they're going to go out. So I'm going to rewrite the one there as negative 3 is the larger value. So I kind of pretend they're equals for a second and do the same thing. I add 5 to each side. So I know, no. We have negative 8 and negative 2. And once again, these are going to be open circles. And that's kind of had to extend my line out a little bit there. But we know the graphs are going out because we're looking for values larger than 3. And those values that are shaded there, we're giving numbers that are larger than 3. All right. On the test there. I want to kind of mention this here. Pay no attention to the man behind the curtain. There was a misprint on the review. There is no number 20. Okay. But 21, suppose the thermometer is accurate within plus or minus 0.3. Thermometer reads 76.5, so we're going to write a value. So what I would do is this. I would take the temperature T and minus 76.5 in absolute value. Because it doesn't matter whether we're positive or negative, and its variance has to be less than or equal to 0.3 to be correct. I just wrote the equation out right there. That's all that we had to do to make that particular one work.